Hi, my name is Shashi Jain. I'm an IoT Innovation Manager at Intel Corporation. And what I do in my day job is do pathfinding with Internet of Things modules. Get to look at wearables, 3D printing, tracking wine bottles. I'm also a 3D printing fanatic, as anyone will tell you. My talk today is about how one of my interesting projects that I'm working on led me to believe that scoliosis will predict how 3D printing will be used in the future. And it's a little bit of a circuitous path, so bear with me. How many of you know what 3D printing is and have seen it? If you don't know what it is, it's the building of an object layer by layer by depositing material only where it needs to be. You see here, it's like a hot glue gun attached to a robot. You're laying down layers. Most people think that 3D printing is good for this, trinkets, plastic trinkets. And they may be right, but in the 35 years that 3D printing has been around, now you have vertebrae being printed. That one's ready to be implanted. What's amazing about that is it doesn't relate at all to scoliosis. Let me tell you a little bit about scoliosis. It is the curvature of a spine, side to side, and it's something that can be prevented by bracing the body, holding the spine straight. Bracing the body is actually an old technology. You can see some from the 19th century here. What the form is a vest that kind of puts pressure on the spine, holds it straight. The materials have changed, but the form is not. Leather to metal to plastic. So about a year ago, I started working with a company called Unique, UNYQ, because they're a startup, right? And then, so what Unique does is they 3D print braces. The form isn't different, the material's not different, but it's a fully digital workflow. So you can do things like put those beautiful perforations in and get customizations and personalizations. Their brace looks like a cami or it looks like a corset, and girls really want to wear this thing. There's one problem though. It has to be worn 18 hours a day for 2 years. So how do you get girls to do that? The answer is surveillance. So what we do is the doctor puts a data logger inside the brace, and it watches how long it's been on, and it has to be on for 18 hours a day. And then every 3 months, the doctor looks at the data, cuts the girl completely out. They don't want to do it. So what we did is we put an Intel Curie module in, which has Bluetooth. Now the brace becomes an app for your phone, and the girls are totally willing to wear it up to 18 hours a day. But what's really interesting is those 3 dots. We also put pressure sensors in, and the magic happened when the designer asked for the pressure sensor data. They took that data and made this. This is a second version of the brace that has removed all the plastic that's not therapeutic. Same function, much more beautiful form. And this thing is turned into a wearable work of art. And this is Grace, she's our first user, and this brace is perfectly form-fit to her body, and it is perfectly designed for her lifestyle. So great, we've done this now for one person, for Grace. How do we do better? Well, the answer is that 3D printing and a little bit of data will give you mass customization. We've proven that we can do it for one person, but we got to look to the process to see how we can do better. So when you're diagnosed with scoliosis, what happens is you have 3 doctor's visits, one for the diagnosis, one to fit the brace, and then one to kind of line things up. Once the person has a design, it's 17 hours of design time in CAD files, and it's awful. So this is what it looks like today for a designer. How many of you are designers? 17 hours times however your billing rate goes is going to be real expensive. And what you have to do as a designer is actually look at this. So in order for you to take sensor data out of our sensor and turn it into design cues, you have to read waveforms and say, oh, right here, this person's, when they're lying down, they're getting a gouge over here in the side. So how do you turn that into a design? Well, you take a little bit of material out. I think a better answer is data-driven generative design. And what this means is we take data out of the sensors, we put it into a deep learning machine, and then we update the app on the phone as well as the design on the brace. So you as a designer will have something else that provides input and makes you a better designer. But the magic of this is if we have a deep learning system to do that, we can put in other data sets like your EMR or your Fitbit, and we can make a brace that fits your lifestyle. So it becomes a circle where sensor data feeds the design system. The design system feeds into printers that are smarter and presumably have an Intel processor in them. And, and everyone is happy, especially Intel. So, again, my name is Shashi Jain. If you're at all interested in the ideas you saw here, let me know. I'm totally willing to talk.